It does. So, welcome back, everybody. Today, we are going to continue up with our rotations, or continue on with them, rather. Now, couple things. Recall last class, what we did is using that fancy tracing paper and a single point, we saw that if we rotate 90, 180, or 270 degrees about the origin, we get some nice things that shake out. So, today, two things. We're not going to need the protractor quite yet. We'll get there. Last class, we were using these rules. We said, let's rotate this 90 degrees clockwise. Now, I want to do one more example just to kind of jump in with it. And we're going to see that maybe, just maybe, we do need to indeed rely on some of the old stuff that we've seen and put some more pieces together. So in our notes, last little example of this type, I want us to reflect, and we're just going to, we're going to rotate by one of those nice angles once more. So let's say it's just segment AB this time. Let's do it 90 degrees about, and we're going to switch it up. Every single rotation that we've done up to this point has been around which point? Like, what did we rotate? We rotated around the origin, right? Do we have to? So no, and in fact, that's really just where we're jumping in here. I want us to rotate AB, and I'll give us the points here in a moment, about the point 3, negative 2. Now, here's the deal with it. We don't really truly need to graph everything. It might help a little bit at first, but I'm going to suggest that you don't really truly need to do that. I'm going to erase some of this stuff, and I'm going to draw on this back screen. If you wanted to graph it, we could, and we'll get some points here as well. So let's say we get point A is, I don't know, 3, 5. And let's start with B is the point, negative 2, 6. So we get some segment that joins those. Now we're going to rotate 90 degrees about this point. Your book notation, the more I see it, the more I like it. I'm going to use theirs here just so we can see it. We're rotating with a capital R 90 degrees, and then all that they do is they specify the point that we're rotating around. Now they might call it point P instead, but this capital R with a sub 90 says rotate 90 degrees, and then that point that we're going around is 3, negative 2. Okay. Now, entirely up to you if you want to graph it. And again, I'm going to stress, I don't think you really need to, but I'm going to do some fancy editing stuff, and you won't have this opportunity, unfortunately. Okay, so I'm just going to really small sketch this, and we'll see here, we get the point. We'll just go 5, and negative 5, and 5, and negative 5, and I'm just going to sketch it just to make sense of it. Now, right now, if I were to look at this segment, AB, 3, 5 lives about here. So there's A at the point 3, 5. I'll make that a little bit more clear. A is the point 3, 5. Okay. And negative 2, 6 lives about here. So here's B at negative 2, 6. Okay, there's my segment. It's awesome. Whatever. However, as we look at this, what I want us to realize is that all of a sudden, 3, negative 2, we're supposed to be rotating around this point here. Okay. This is fundamentally different than the problems that we did the other day, right? Because we didn't have to change anything. This problem is harder. Could I give you the tracing paper? You could graph everything, and then you could put your pen right down here and rotate it 90 degrees and get the same answer. You could. Does anybody want to have to use tracing paper and graph it every single time that we do these, though? Okay, why is this problem harder than the ones we were doing last class? Something changed, and I highlighted the difference, but if you didn't catch it, check your examples. There's only one thing different about this problem compared to all the others that we did.
It rotates about 3 degrees.
This point is hard to rotate around, right? All of our rules that we worked out in our last class, it was entirely focused around going about the origin. Now, this is a harder problem unless we try to do something in order to make it another easy problem. If I wanted this point, our center of rotation right here, to be at the origin, where would I have to move it? Which direction and how many? So right now it's at 3, negative 2, right? If I wanted it to be at 0, 0, which direction, left, right, up, down, and the combination thereof, but I have to move it so that this red point, we're back at the origin.
2, left 3.
So I'm going to change the order, but I agree with you. Left 3 and then up 2. Does everybody agree that that would move that point to the origin? Now, here's what I'm thinking. Rather than trying to deal with it and create a new rule for every possible point, if instead I simply, I don't know why that one didn't disappear. If instead I was able to do something like this, and I'm going to cut that one out. Here we go. If instead of where it was, oh my gosh, I'm trying to be so fancy, but it's not working. Okay, done with that. If I took every single piece and moved it left 3, up 2, is it the same problem? Now, here's the whole approach. We're going to take everything. We're going to move it left 3 and up 2 so that that center of rotation is back at the origin, but it has to happen to all of them. So what we're going to see out of this, and I'm going to come back to that. We'll just turn that one off for now. Get out of here. We can't do this yet. So that's unfortunate. And I'm going to actually highlight with that, we just don't have a rule for this. Our rules are about the origin. So sad face, we don't have rule. Now, if we realize that just by moving that center of rotation back to the origin, we now do have rules, everything gets easier. So what we can do then is on A at 3, 5 and B at -2, 6, let's just move everything. And Lily, you told me a second ago, if we want this point to become the origin, how do I move it?
Left 3, up 2.
And if I'm just moving everything left 3 and up 2, that's a rigid motion that we've already discussed. What's that rigid motion if I'm just moving its location? It's a translation. So we're going to translate to move everything to the origin as our center of rotation. Okay, this little step, move center of rotation to origin. That's all that's happening here. Now, everything has to move. The good news is that these rules are pretty chill and easy. If I wanted to translate every point left 3 and up 2, if I move this point left 3 to get to A prime, where would it become?
0, 7.
Harbor claims 0, 7. Do you guys agree with that? Okay, how did we get that? We literally just went to the x and we subtracted 3, and we went to the y and we added 2. Okay, new rule, just to encourage other people. I don't do a whole lot of hand raising stuff in here, like it's just not really my style. We're going to say different person has to answer every question. So just nobody can repeat twice in a row. Not that I don't like everybody's opinion, but I want to make sure it's there. Carson, if this point moved 3 left and up 2, where would it become?
3 left.
Uh-huh.
-5, 8.
Okay, everybody cool with that first step? Now, we are adding a step into this problem because it makes it easy. Everything is rotating about the origin at this point. Once we're at the origin, can we rotate easily enough? Like, do we have a rule to rotate 90 degrees? I think so. I don't remember it, unfortunately. So I'm just going to say 90 degrees. And now we're at the origin, which is going to be nice. Our center is. So I'll say origin. Gosh, what's the rule for rotating 90 degrees? For the record, I don't expect you to just memorize it, but if you turn... So they swap places and the front one changes signs. Love it. So swap places, it becomes 7, 0, and then this front one changes sign, right? -7, 0. Okay, which means B double prime, if we're looking at it, switch places, we would get 8, -5. But if we change the sign of the first one, now it's -8, -5. Have I lost anybody? I'm using this rule right here. X, Y, they swap places and the first sign changes. Okay, now you're going to be tempted to say that you're done, but check it out. Instead of rotating around this point, essentially here's what we've done. We moved, now I rotated, and if I want to be back in my original location or where I ought to be, if I started by moving 3 left and 2 right, I should undo that. So how do we undo a left 3 and up 2 to move back to as if we were just in the same spot the whole time?
Right 3, down 2.
If I move right 3 and down 2, it just puts everything back to where it would have been, right? So we'll do that just to undo and solve everything. And we are at our last step already. Here we go. We'll say it's now right 3, down 2. And I'm just going to go ahead and denote here undoes, for lack of a better word, our first translation. Now, that first translation was only there to make it easy to use our rules about the origin. Cool. So last little step. A triple prime might be how we refine this or call this. Where should this wind up? What do you think, Andrew? If I move this 3 to the right, if I was at -7 and I add 3, what do I get?
10.
That's if you subtract. What if we add instead?
Add -4.
Good? And Ashley, in the y direction, if I was at 0 and I went down 2, where am I now?
-2.
Love it. Camille, B triple prime, where we end. If I moved this point right 3 and down 2, where does it wind up? So you're super close. There's a little mistake. If we subtract 2 from this, what do we get? -7. Now, we have to move it to make it a nice problem, but in a lot of math, that's all that happens. Make the problem easy, solve it, and then change it back to what was the quote-unquote hard problem. That's all that we have to do here. Now, notation-wise, here's what I'm not really sure that I need your guys' input on. It's gross to have to call this A triple prime, because really we're just doing a single rotation. This should probably be A prime, right? Now, here's how your book refers to it, and I like the language. These steps right here, whether we want to use that prime notation or not is up to you. I don't mind if we call our answer triple prime or single, but these, your book refers to these as the intermediate steps. Now, with that in mind, intermediate steps. If you don't want to use A and B and just show the points and then switch to just A prime and B prime here at the end, I'm okay with that as long as it's very clear what has happened. All right. This problem, a little bit more involved. Is it truly more difficult though? If it's not the origin, what do we do? Let me rephrase that so it's a much more clear question. If we want to rotate about a point that's not the origin, what do I do? Move everything however far to get the center to the origin, right? Okay. Looking at this, do you want to do another one here, or are we content just to say we can move it, rotate, and move it back? Content creators. Okay. Here's the last little piece. Kind of. So last class we were rotating completely on the coordinate plane. Do flat surfaces or planes exist out there that don't have Cartesian coordinates on it? Yeah. Now, even if you have graph paper, if I said, hey, let's rotate 15 degrees, does a graph paper really help that much anymore? Not super. So we're going to do a really, hopefully brief thing where our second little focus within 3.3 is let's rotate without coordinates. Without coordinates. Now, you could go through the painstaking process of working out a rule for rotating by 1 degree, by 2 degrees, by 3 degrees, so forth and so on. We only have 90, 180, and 270 at this point. We could go through and get all of them if we really wanted to. However, I don't think we want infinitely many rules to have to follow, so we need a way to do this without that. All I'm going to do is I'm going to get a piece of scratch paper, and we're going to do one quick segment just to make sure that we can see how it's done with the protractor, and then we'll move on from there. Anybody have questions? I'm going to use the document camera with stuff. Let's make it as nice as possible. So I'm going to grab me. I can't believe that didn't just shut itself off. That was pretty sweet. I'm going to grab my protractor as well, and we're going to rotate one time on the flat plane. Okay, what shape are we rotating?
Square.
A square. I'm okay with that. Fine with me. Okay, so rectangle at least. And I'm going to put this on here. We'll turn it on. And let's go ahead. We're just going to do one example here. Okay. So I'm going to rotate a square. And I'm going to draw it fairly small. So here's our example. And I'll try to zoom in. And we'll brighten it up a little bit. Okay. I'm just going to make it foregone. It's not going to be a square. And I'm going to make it actually not look super duper square. So it's easy enough to tell these sides apart. So an ugly foregone is what I'm going to rotate. Okay. We'll call this foregone Q, U, A, and D. Now, I'm going to rotate this thing about some point. So I'll just go ahead and say rotate about, let's say it's point P. And I don't know where point P lives, but let's say it's right, I don't know, down here. Here's point P, somewhere down here. Okay. Super duper important. If I do something that you're not sure what happened or you get hung up drawing, whatever the case is, should you just not say anything and let me keep going and then ask me in 10 minutes? No. Okay. We're going to do our first point together. If we need to do another one, we will, but we're going to go through this process. We're rotating about point P. How many degrees do we want to do? It's not going to be one of the nice ones. It can be anywhere between 0 and 360 without 90, 180, or 270. So between 0 and 360, let's pick a fairly nice thing. Let's say 40 degrees. Now, first thing, when I say 40 degrees without specifying, that tells me, is this clockwise or counterclockwise? Always counterclockwise. Okay, just like our quadrants go 1, 2, 3, 4. Now, we can work out steps like here's step 1, step 2, step 3 if you guys would like. But if we talk them, I'm going to tell you honestly, I might ask you to do some basic ones with these, but it's not going to be super hardcore. It's just nice to see. You guys don't have a ton of experience with these things, I don't believe. So we're going to get some. Okay, first thing that we're going to do is if we're going counterclockwise, I realize it has to go like this. Everybody cool with that? Okay. Now, looking at this, I'm going to move point A first. And here's how we're going to knock this out. I'm going to step 1, and this is going to be repeated with every step. Step 1, I'm going to connect A in this problem with my center of rotation. So I'm just going to draw a small dashed line. Those are connected at this point. Now, if I'm going 40 degrees, it can be kind of hard to work this out. These protractors, they can only go up to 180, right? So we're going to check something. Here we go. Step 1 is I'm going to line up my protractor so that this line on my protractor is exactly in line with that dashed line that I've drawn, but the center of my protractor is right here. So it's not going to be perfect, or it will be because that's awesome. And a couple other things work out really nicely here. Do you guys agree that that is about lined up pretty well here? Okay. Now, here's something that I'm not going to have to do because mine is super nice. Purely by coincidence, and it's awesome this worked out. I know whatever distance this is from A to P, when I get to A prime, it's going to be the same distance. Like all distances are preserved. Now, we need to rotate how many degrees? 40. So check this out. If I zoom out a little bit, now I'm coming from this side so that I'm looking at this from the base. And we could turn the whole page if we wanted to, just so you can see it. And in fact, I do. I'm looking at it essentially from this point of view. Everybody cool with that? Now, I turned my physical page. You don't have to. You can. But I'm doing this because I see a couple things. This right here indicates 0 degrees. Okay. Now, we need to get up to 40 degrees. So starting at 0, I'll use the inside since I need to get up to 40. I'll go 10, 20, 30. There's 40 degrees right there. As long as I'm still lined up, I'm going to make a little tiny mark at 40 degrees. Okay. So all I've done now is I found where's 40 degrees of rotation from point A. Now I did it all the way out here Does everybody have a mark at 40 degrees when this is lined up? I'm going to ask you guys to show me your mark first. So you're close. I'm going to let you keep touching it because I don't want to touch it yet. And just see. Awesome. So you're going to get that perfectly lined up. Good. Just like that. And we'll start lining up in the center. And you're going to mark at 40 degrees. It's going to be weird. It's going to be in your stuff up there. We haven't marked. I want to see everybody's 40 degree mark. 40 good. 40 good. And you can do it on here. That's fine. Just go ahead and do it. So careful. We're going point B. We want to put it right here. So that the center of our rotation is at the center of this. And now we're going to mark our 40. So you get that lined up. I'm going to mark it. And you'll just mark it on your thing. So we don't need to do another mark. You have 40. Sweet. Looks good to me. Were you able to get 40? Looks good to me. Almost. Let's double check. We're going to make sure that this lines up a little bit nicer. So right in the middle. And I'm lining up until this line right here gets to 8. And I'm going to change it. You're not very far off, but barely off. Like that. Close enough that I wouldn't cut you on the test, okay? All right. Now, here's the deal. Distances are preserved. Mine is purely by coincidence super nice. Do you guys agree that point A just happens to be right at the end of this first line? Like if I put it there, I can see point A is like right at the end of that line, right? That is pure coincidence. Okay, when you're doing it, and in fact, I'm not going to use that. Here's all I'm going to do. I'm going to use, whether it's metric or not, doesn't matter to me, but I want you to measure the distance from A to P, the original. I see my distance is 1.5 centimeters. What is your distance from point A to P, or vice versa?
1.1.
1.1. Awesome. Same. Okay. So check it out. If you have that distance, you might want to write it down so you don't forget. I'm going to write mine here, and I'll just put it back like it's normal. So I just found 1.5 centimeters on mine. Okay, I'm going to double check. Do you guys agree with 1.5 there for me? I think it looks pretty close to 1.5. Cool. Everybody have that distance marked. Okay, so just to kind of review stuff, we found the 40 degrees with P at the center of our protractor. We marked the 40 degrees, and then we measured the distance from P to A. Now, what's super cool about this is that P to A and P to A prime are the same distance. We don't change distances from it. So here's all I need to do. I will then line up my protractor, and if I have that distance measured in centimeters, for example, if I line it up, and here's my 40 degree mark, I know that from P to A prime should be, on mine was 1.5. So check it out. I'm going to draw. Here's 1 centimeter. And then another half. Here's my point A prime. I just simply went until I was lined up with my 40 degrees, and I measured the same distance away. This angle right here is my 40 degrees. And I can see that it happened. I don't really truly need these dashes, but it does help to measure stuff. But I get two distances that are the same, and it happens to be 40 degrees between them. This is my 40 degree rotation to get to point A prime. Should we do one more point together? Or do you want me to talk through one more point? Okay, so you can do this at the exact same time if you want. I'm cool with it. Once I have my first point, and I was shocked that you chose a foregone. I was expecting a triangle because there's less points, a segment possibly, but I'm cool with this. I like the keep me on my feet. So check it out. I'm going to do the same exact thing, except I'm going to line it up this time with point D. Now, this one is not the perfect distance. I'm going to switch colors just so it's a little bit easier to see. I'm going to do the same thing. I'm going to draw a dashed line here, and I'm only doing this so that I can measure super easily to make sure that I get to the right value. Okay, here we go. Point P, I'm going to line it up now along my red dash. And how many degrees are we rotating? So check it out. Same thing. Center of rotation right in the center of my protractor. I'll go to my 40 degrees and I'll make a mark.
Wait, are we writing this one or just talking about it?
I mean, I'm doing mine right now. You could be doing yours at the same time. I've drawn a line from D to P so I can line up my protractor well. Put the center of my rotation right smack dab on P, and then I marked out my 40 degree angle again. Now, I don't know why it's a little bit off when I came back to it, but we're gonna fix it. So 40 degrees is actually about right there. We'll do right in that longer step. Okay. Before I draw my next line, I now have that measured out. I know where my 40 degrees is. What should I do? How do I know where point D goes on this dash line? So there's my 40-degree angle between the reds. How do I figure out where D prime goes on that new dashed line? I'll let everybody catch up because it feels like it was a rhetorical question based on your feedback. Hey, let's just measure that same distance, right? From D to P, it must be somewhere on here, and I can like eyeball it out. It's probably close to that line. I'm gonna just measure the distance. So I've drawn the line, I lined up my protractor, I marked my 40 degrees, and then the only thing I did different was I extended this one all the way out. Now, if I measure from there, I get 2 point, I don't know, what would you guys say my distance is here? 2 point, so 2.4. So I'll come along the same line and I'll go out to 2.4. And I hate that it is going to land on that exact same spot, but here's my distance of 2.4. Here is D prime in this problem. Now, if AD is this line, what I see is that here's, I'm going to use a pencil instead so it's a little bit clearer. Here's A prime, D prime. Does that new line I just drew, weird, look to be the same distance as this one? DA and D prime, A prime, do those look to be the same line? Or segment, rather? For sure. I'm going to give you guys a moment to finish with points Q and U. Let's see if our points really and truly do, or our rotation really does look the same. It should be pretty close as long as we're measuring comfortably. I'm going to give you guys a head start before I come up and finish mine. I'll pick a different color for each piece so we can see them a little easier, but I'll give you a moment. I want you to now do points Q and U. Really ugly. First thing, we're just going to say with protractor. And then, I don't know, either a smiley face or a sad face if you like working with the protractors, or don't. Like it, I don't really care, no offense, but your opinion on your protractor stuff. Have you guys done a lot of protractor work in any of your other classes? Is this the first time you've ever used a protractor? We might have used it for a minute in physical science. I don't recall. I don't think we did any crazy vector stuff there. Okay, with a protractor, it's doable. Now, as we move forward, I'm not going to spend a ton of time on that one. We get one last little theorem that we're going to knock out. So we're going to look at compositions one last time. So composing two reflections. Now, this is going to wind up as being a theorem, but if we compose two reflections, the wordy version of this is awful, just for the record. It is not pleasant. We're going to deal with it. Okay. We're going to look at this, and we will spend as much time as needed to be able to sort this out. But here is our theorem, and I'm going to give us the picture version first, and then we'll decide on the words, because the wordy version is like 3 sentences, and it's blah. Check it out. If you don't have color pencils, or if you want to shade, I would strongly encourage it. I'm going to draw these two lines. Very similar to our bell ringer, but this time we're just going to use a segment. Now, if we have L and M, we're only going to make a single segment. And let's make it so it's easy to draw. Let's say here's our segment. A, B. A and B. Okay. I am going to reflect twice. Now, we already have a theorem that says if the lines are parallel. This, I don't think is that. Are these lines parallel? L and M in this picture.
No.
How do you know that?
They cross.
They cross. That's like the opposite of what it means to be parallel. I don't know if the opposite's the right term there, but I think you guys get what I'm saying. Okay. If we wanted to, and I don't really require that we do, I could sketch the intermediate, the middle step here, and I'm going to do it really lightly. Do you guys agree that B would wind up about there if I reflected? B prime, rather, because it's perpendicular and equidistant. Is that about B prime? Okay, and then I'll do the same thing here just to eyeball it out. Means that I think here is about A prime if I do it. Now, I'm not really going to truly write this one down. I'm just going to keep this as intermediate. I'm not even going to call it prime and stuff. Because eventually I'm going to erase this one, just so you know, I'm just using it to help me. Could I now reflect this over line M? And can we eyeball it reasonably well again? Okay, here's the weird part. I know for a fact that I can. Can you guys eyeball where the next one would be reasonably well? Like, if I'm here, how do I decide where B reflects when it goes over here? I'm going to say 30 seconds chat with your neighbor because I'm going to make somebody answer that question. How am I eyeballing, without measuring, how am I deciding where B goes when I reflect over M? Do we agree that we just go equidistant at a right angle? Yep. So now, I'm going to erase that middle one here in a second, but there's B prime. And then A prime, if I do the same thing, and I can erase mine, which I know you guys can't do that quite as well. I think it's about here. Okay. In this situation, we see something awesome happen. And I will actually kick back to make sense of it with a real, way better rotation. But I'm going to erase my middle step here. Okay. That was just to help me draw it. And I'll keep it. I lied. I'm going to get rid of it. Now, if I come back to the example that we did just a moment ago on our scratch paper, I can measure angles no problem. Hypothetically, let's say that this right here, right in the middle, was X degrees. We're going to hit the conclusion of this tomorrow because protractor stuff always takes forever. You guys dodged a bullet. We're like 4 minutes out from being able to do homework. So come tomorrow ready to do homework. We're about at mid-chapter, too, just throwing that out there.
What?
We are about at mid-chapter.
Jeez, I think we haven't had it tested forever.
It's been like a week, but yes. All right, enjoy your no homework.